I am Orneda Lecini and I'm from Group of Us. Today I'm going to do a presentation about AI called BirdNET that is listen to bird sounds and identifies them. We are very exciting to use these open source technologies to to solve real world problems, which one of them that is very critical problem is our planet's biodiversity. I'm going to show you how we use this AI and how we as free software communities are using that in our the Rainforest project. So let's take a look at this image. We see on the left side we see a person that is in the woods. It looks like a relaxation place. We listen to the sounds. But imagine if you are a biologist. You listen to a sound and is that blue tit, it's a robin, it's a wood pigeon. And imagine if you are doing that for 8 hours a day and in 50 different locations. It is clear that the data will be very messy, it is very exhausting and very costly as well. So that's how the traditional monitoring works, but what we put this kind of efforts in a system that monitors 24/7 continuously and never gets tired and identify dozens of birds. And there we can, that's where we use BirdNET. BirdNET is an open AI system, and that's a first point and the most important point of this conference. And it is fully fully built in transparency and collaboration. It is a convolutional neural network, and you can think of it as a master pattern recognizer. It is trained on a million labeled birds, and each of them has a pattern, a unique pattern, so it's different from the others. And as a result, we can get over 3,000 species worldwide. And something that is very important and makes this algorithm very efficient is that it runs offline, even in small devices. So I'm going to explain this how it works. It's very simple. We have the first step, audio recording. The microphone captures a sound. Then we have spectrogram generation. Spectrogram is a visual image that contains patterns based on that audio that it was heard, what is captured. Then we fed up this spectrogram image to the model. It is a BirdNET model. It can be the original one or a fine-tuned model. And after that, we are able to get the result. What is the result? Result basically says that we have this visual pattern, this spectrogram is, let's say, 83% similar to this kind of robin. So in the end of the result, we have the name and the confidence score. Why this tool matter? Let's step a bit back from technology and focus on real-world problems. On North America, we, like from 1917, 2.9 billion birds are gone. So we can see that by monitoring is very important, and we can see that by tracking, by monitoring the species that are that are in the nature, will be very helpful to see if our planet is in trouble or to see the health of our planet. And that's why we use BirdNET. BirdNET, except the fact that it costs less than and is not limited as the traditional monitoring. It also is non-intrusive, which means it reduces stress in the wildlife, or let's say also there is no stress in the wildlife since the capturing is not with the detection of the sound is without capturing, no tagging, just listening. And then it is continuous. We also can get long-term population trends based on the data that we can get from BirdNets. And hopefully, finger crossed, we can say that AI will not replace nature or code lovers, but it will help us discover what we have been missing all along. At Group of us, we are using BirdNET in the Reinforce project. Reinforce project has the goal of this project is to find new evidences, and by using these new technologies, and also is focused on strengthening the role in biodiversity. Our project basically contains a shelter that is created with 2 cameras for image detection and a microphone for sound detection. Let's focus on microphone part for the sound detection. It has a continuous recording, and as soon as a sound is detected, it is saved. It is passed through the BirdNET. BirdNET analyzes and identifies the species. The species are saved in a database, a central biodiversity database, when we monitor and analyze it. In our data, each detection includes species name, confidence score, timestamp, and we have GPS location data and some environmental data by using the sensor. These data are visualized in dynamic dashboards, and this part supports researchers and conservation to hotspot the biodiversity. And most important also is it's an important fact that it tells local and farmers communities that to knowledge the surrounds in the nature that they live in. A fact, BirdNET can recognize a single robin song in more than 100 notes in 10 seconds. Imagine now how many years and hours in fields can take for a person, let's say a biologist, to get trained to get this recognition like in this detailed mode. It's like impossible, like it will take a lot. So imagine if those data that we have, we use for the BirdNET, and we get this system which works like, let's say, perfectly. This is a dashboard from our Reinforce project. There is the table that in a week, in a location called Villa Lebret, is there in a week we got 313 records, and with different type of birds recognition, which we can get in conclusion that this data, dynamic density of data and diversity is very, like it's a goal for the researchers to have this kind of data in a week. So why am I presenting BirdNET in this conference? First of all, BirdNET is built in open source and free software. Like, these are the principles of BirdNET. The code and the models are open source, which helps everyone to inspect, to improve, and to reuse this kind of codes. And it I will not say that it's just a research tool, but I would see also like a citizen science tool that encourage collaboration between people to improve this tool. There we have a unique scenario. I don't know if the video can be played. It's basically a parrot that tried to say thank you. And there is the human voice as well. And I passed this video with BirdNET, and I was able to get this recognition. The first one is a kind of parrot. I'm not saying the names. The second, human. The third, another parrot. And the fourth, robin, a bird. The first and the third recognition that our parrots are very similar to this type of parrots. So I would say that this kind of, as you see, you can see the confidence. This kind of detection with the confidence is quite good. Also the fact that it was able to detect the human voice. I don't know if the video can be played or... I would say that that's a unique scenario since it was not very clear, plus the parrot was trying to say thank you, so it's quite a good result. And thank you. Thank you for your attention.
Question? Yes. Thank you. It's coming.
Hi. Thanks for the Vortrag. It's more a comment than a question, because I also use as a private person this app since 1.5 years. And I just wanted to mention that using this app was really changing my view on walks and in traveling, because I was in 7 countries and heard some birds which I didn't know. And then to see which bird it is was really another kind of traveling. Yeah. Just wanted to say that even for a private person, this app is really a nice tool. If you go just on a walk and hear the birds, I go then with my mobile phone and search for them, yeah, kind of. And it's nice to see. Yeah, I just wanted to say that.
Yeah, that's very true, actually. Based on our data in dashboard, we see that different type of birds there are detected, and probably we as human say it's just one type of bird. We don't recognize it like bird and point like dot. But as biologists, probably it's very much more fascinated, this part.
Do you need a common microphone or something sophisticated? Do you need a special microphone to hear the bird voice?
I didn't get it, sorry.
Microphone. Do you need something special to this project, or you need common technology?
No, actually, also the microphone has to be with, for this kind of technology, it works also.
Human frequencies.
Yeah.
Okay.
Human frequencies, exactly.
Ah, okay.
So.
Okay. Yes.
What I want to ask is the work of classification, so I mean the human work to classify all the information, in any case the correction of human, is something that all this data set and the work on is something that you have done, or is something that was already, I don't know, in a database, I don't know.
Till now, all the data set and all the models are taken online, are already prepared. We haven't apply yet our data, but we are saving our data that we are collecting data. So for the future, we probably will train it. But at the moment, everything is online and free.